Dear students, today I'm going to discuss about the Fourier series method, like how to design a FIR filter in a Fourier series method, right? So Fourier series method of designing a FIR filter. As we know, the Fourier series can be expressed as a function of periodic one, right? It can be expressed as a linear combination of complex exponentials. FIR can be represented by the Fourier series formula like ht of e power j omega equal to summation n equal to minus infinity to infinity ht of n e power minus j omega n. This is the Fourier series formula. Here ht of n is what? Is an impulse response. This is frequency response. Now the impulse response sequence of the filter is written as ht of n equal to 1 by 2 pi integration of minus pi to pi ht of e power j omega into e power j omega n dn. This is the formula for the impulse response of the filter. Now that frequency response can be represented in terms of the Z transform. So Z transform of sequence is h of z equal to summation n equal to minus infinity to infinity ht of n into z power minus n. Right? This is the formula for Z transform. But here the impulse response is represented as a non-causal sequence, right? Why we can say it is a non-causal sequence or non-causal filter? The summation is represented from minus infinity to plus infinity. So it's a non-causal filter. Non-causal filter means it having both positive and negative duration ranges, right? Which means it depends on both the present, past and future. That's why we can say it's a non-causal sequence or non-causal filter. But our design is what? FIR filter. FIR means finite impulse response. But here we are using a impulse response is a infinite duration. So here we have to convert this infinite sequence into finite sequence. For that I am going to do the truncation of this sequence. So by performing a truncation we can convert this infinite duration to finite duration sequence. So for the truncation, here we are assumed that h of n equal to ht of n for mod n value less than or equal to capital N minus 1 by 2, right? Capital N minus 1 by 2, okay? This mod n is nothing but it's a representation of positive and negative. So the n value is minus n minus 1 by 2 to plus n minus 1 by 2. For remaining the n range become otherwise. So here the n duration is minus infinity to infinity, that is minus infinity to infinity. But after truncation with this condition, this is the n, okay, n. The n range is minus n minus 1 by 2 to plus n minus 1 by 2. So the infinite is converted into finite duration, right? According to this statement, we can rearrange this equation h of z equal to summation n equal to minus n minus 1 by 2 to plus n minus 1 by 2 h of n z power minus n. Then expand the summation term, right? Expanding the summation term. So here substitute the n value. So first is h of minus n minus 1 by 2 to z power minus n. So minus into minus plus n minus 1 by 2. So likewise we substitute the n value. Then h of minus 2 is z power minus 2. H of minus 1 is z power minus 1. Then plus h of 0 plus is z power 0 1. Then h of plus 1 is z power, sorry, here is z power plus, right? H of minus 2 is z power 2. H of minus 1 into z power plus 1. Here then positive value h of 1 into z power minus 1. Then h of 2 into z power minus 2. It goes on. Then plus h of n minus 1 by 2 to z power minus n minus 1 by 2. So this is the expanding of this given summation, right? So in this expression we can simplify it as h of 0 is separate plus summation n equal to 1 to n minus 1 by 2 h of n is power minus n plus h of minus n into z power plus n. This both is same, right? Because if n equal to 1 means h of 1 is z power minus 1 plus h of minus 1 is z power plus 1. So both term we are having here h of minus 1 is z power plus 1. Then h of 1 is z power minus 1. Likewise, if you substitute n equal to 2 means h of 2 is z power minus 2 plus h of minus 2 is z power 2. Then n minus 1 by 2, h of n minus 1 by 2 is z power minus n minus 1 by 2. Right? This last term. Then h of minus n minus 1 by 2 to is z power plus n minus 1 by 2. Right? So we can rewrite that expression into like this. So again, for symmetrical impulse response having symmetry at n equal to 0. So symmetrical impulse response having symmetrical value at n equal to 0. So the symmetric condition is h of minus n equal to h of plus n. So we can take it as h of minus n is h of n for a symmetric impulse response condition. So again it changed as n equal to 1 to n minus 1 by 2, h of n both common. That is h of minus n is replaced as h of plus n. So h of n is common, z power n plus z power minus n. Anyhow, this is not a practically realizable. For getting a practically realizable one, we again multiplying this h of z into the delay element z power minus n minus 1 by 2. So z minus n minus 1 by 2 into this h of z. Then it become a realizable FIR filter. So that is denoted as h dash of s. So h dash of s is equal to z power minus n minus 1 by 2 into h of 0 plus this term. So this is the flow of method in Fourier series for designing a FIR filter, right?